Welcome back to the Startup Show. I'm John Biggs. Today on the show we have Philippe Noel. He's the CEO and founder of ParadeDB. This is going to get kind of dorky, Philippe, but welcome. I think everybody needs a nice lesson in what ParadeDB does and why it's important.
Hey, thanks for having me. It's good to be here.
Yeah, tell me what you're up to.
We were building a competitor to Elasticsearch, so we are building a database product, which is used by the people that make software that you use on the daily. If you imagine you're going on Facebook and you want to search for someone's name to send them a friend request, well, you need to store information so that it can be searchable in some sort of database when you're building a software product. We build one such database.
Okay, so very specifically, if I have a search function on my app or I have a search function on my website, you guys are building a different version of that. And is there already there's already an open source version of something like that, right? Am I right about that?
We're building the database that allows you to build that search function on your app or website. So they're sort of the behind the scenes of what the user might use. And there's many options that exist out there. We're building a more modern version of a pretty popular open source project called Elasticsearch, which by now it's a good tool, but it's starting to show its age.
So it's Elasticsearch is basically you could embed Elasticsearch into your product now,
Sure.
and it would work fine. But what you guys are saying is that this thing that you're going to sell is going to be better than that tool. That's
right. That's the hope. At least in perhaps not in all cases, but in many cases nowadays. We focus specifically on the market of companies that use Postgres. Postgres is a pretty popular database framework, and we give much higher quality integration and experience for companies that use Postgres and also want to do search.
Why did you want to solve this problem?
It's a problem we experience ourselves. Me and my team, we were previously building in the supply chain world, actually. And as part of the experience as part of the product we were building, we needed to use both Elastic and Postgres, I was mentioning, those two databases to build the application we wanted to build. And it's famously difficult to operate both at once. And we thought if we could actually sort of have these capabilities inside of the database framework we use inside Postgres, we would not need to use this 15-year-old cumbersome Elasticsearch tool. And so that kind of got us started on the space.
And Elasticsearch does the crawling for you too, right? Presumably, if you have like a website, it would crawl the website to find all the stuff for you.
When you use it, you decide what you want to index with it. Yeah, but it does the indexing.
Oh, I guess you're right, because you're not actually indexing web pages, you index a database.
Yeah, you would index like a data set. So if you're building ZocDoc, you might want to index the list of medical practitioners that you want to be searchable for, right? Or if you index Facebook, it might be the posts that people have made or their name, so you can send a friend request or things like that.
Now, you guys are doing a lot you guys are replacing an open source product. What happens when you try to pitch that story to folks who say, well, I have this, it works fine, it's free?
Well, there's a few. First of all, we're also an open source product. Right?
Oh, okay.
So that's also part of it. But there's a couple of components. Nothing is free, really. Even when you use open source products, you need to run them on some servers in the cloud, right? And Elastic, for instance, is famously expensive and difficult to run. So it requires many machines, many servers in the cloud. You oftentimes also require many employees to be able to run them at scale. And so when you're operating this tool, you have two options. You can use the free option in that you don't pay money to the company making it, but you pay money in salaries and in server costs that you run yourself. Or Elastic will say, hey, pay us, and then we'll do all of that for you. Right? But either way, it's expensive because their tool is not fully efficient and so on. So it's quite expensive to orchestrate whether it's done by you or by them. We build a more modern version that is much lower footprint. So whether you run it yourself or you decide to pay us, it's going to cost you much less money. You're going to need less, attention from your employees on operating the tool, which is lower salaries or more attention spent on actually driving business for your company and so on.
Yeah, I just noticed that you could. It's basically just a Docker. I could just basically do a couple lines of code or a couple command lines, and I'd be able to have it ready to go. In theory,
yeah, that's right.
But eventually there will be a situation where I'm like, "Hey, Philippe, can you fix this for me? Because I just messed the whole thing up."
There's hopefully there's not too many, but yes, we're there if you need anything. It's meant to be easy to use.
Okay. What inspired you to do this? You talked a little bit about that you had this problem before, but why? Again, there's a million things you could have solved and a million things you could have solved in a non-open source way too, I think. What inspired you to do it this way?
That's a good question. I mean, we're big fans of open source in general. The good thing with open source is you can almost think of it as a model where the wealthy enterprises subsidize the product for everybody else.
That's what we hope, right?
Exactly. And so the idea is, hey, we wish we had access to this. Building open source is good in that you can easily share it with people. You can get feedback really quickly from sort of a selfish perspective. It helps us build the right thing for the right people faster. But also it means hopefully as we, keep growing the company, we make money by selling the product to big enterprises that require support and complex features and so on. But we can keep the core of the product free forever for anyone, so that if you're on a weekend and you want to build a project, or you work at a startup or a nonprofit or a smaller organization, and you have those needs, but you don't have the bandwidth to put money on it, you don't need to, right? And philosophically, that's a model that we really like and that we would try to support.
How do you raise investment for a project like this?
Same as any other product, really. Like, just because it's free for the entry level of the market, it doesn't mean you can't make a lot of money. And Elastic, the company behind the original project, they're a public corporation today. They make over $1 billion in sales every year. So, it's certainly possible to make a sustainable business, even though, you try to give some of it away.
Mm-hmm. Yeah, I'm worried about the VC who says, okay, well, you're just giving this away, but then you point to Elastic, or you point to you point to everybody. You point to GitHub, you point to there was another guy who just went public, I believe, in the Git space. So that stuff works. Why?
It works, but it's not easy.
Yeah.
You are watching the Geek Nader podcast, and we are here to make you curious and inspire you with our deep tech talks on distributed systems, databases, stream processing, and general software engineering. Now, so I want to understand the historical context about ParadeDB. How did you come up with the idea, like using Postgres and like building search and analytics engine on top of it? So what was the problem that you were trying to solve?
That's a good question. So we started a company last summer, in summer 2023. And at that time, we were talking to a lot of engineers. In fact, we had worked doing some projects with a few companies where they were interoperating both Postgres as their primary database for storing, backend data, and another tool called Elasticsearch, which is pretty popular to do very complex full text search, or like search like experience within an application. And they needed to use both tools and send data from Postgres to Elastic. And the more data movement you do, the more complexity comes in. And Elastic has a lot of good benefits, but it also has its limitations and its sources of trouble. And so many of the people we talked to were kind of frustrated with that, and that got us interested in the space. And we thought we might be able to sort of upscale Postgres so you could remove the Elasticsearch part of that and have a much simpler infrastructure. And that's kind of how we got started.
Okay, interesting. And I guess I know the answer, like why Postgres, but I will still ask you, why Postgres? Did you also try some other database?
No, we didn't. Postgres is wonderful. There's nothing better. So I think Postgres is by far the most loved database nowadays. Whenever people build a product, they first start with their database, and overwhelmingly nowadays people start with Postgres. It's very rare that people adopt other databases, and when they do, oftentimes it's people that already did, big companies that did a long time ago, and those companies are moving to Postgres. There's many reasons why people love Postgres, which I'm happy to talk about. It's open source, community is very strong, it's obviously very reliable, and so on. But for all these reasons, we decided we were just going to do one thing and do it right, and we thought the best thing to do was Postgres.
Yeah, that does make sense. Postgres is such a vast ecosystem now, like so many users use it for different purposes. And I also love Postgres. Like I've been using Postgres since many years now. And that's why I said I probably know the answer, but I'll still ask you. But yeah, thanks for sharing that. You mentioned Elasticsearch, and I've also used, in my experience, whenever we need a full text search, we need some kind of search functionality, let's spin up a new Elasticsearch cluster, ingest data, and then the data is searchable. That's the traditional way of doing search. And the problem I have faced typically is, of course, maintaining another Elasticsearch cluster itself is a big pain, especially if there is a ton of data. And then maintenance work like upgrading Elasticsearch versions and making sure there's no regression and performance stays to the mark and all of that. So it's pretty challenging to have an Elasticsearch cluster. I'm sure there are other challenges, but I would love to take an example here. Let's say an e-commerce application where people can search for products and do some advanced search as well. And of course, they have transactional workload as well, right? Like creation of orders, things like that. So how would the architecture change when I remove the Elasticsearch part and try to embed, let's say, ParadeDB?
Yeah, that's a good question. It depends on the exact use case. So in the example of an e-commerce company, there's a few things. Like Elastic is pretty good if you have data that's not changing very frequently. So it works well, I would say, for some e-commerce, for example, because you can sort of index your catalog once, right? And then assuming it doesn't change very much, you don't have to worry about data movement so often. You can even do it manually in some cases, right? And that removes the number of moving parts. But typically what people will do is they will start with Postgres, right? They'll have Postgres as their source of truth. It's very rare that people believe Elasticsearch is a source of truth. And so if you don't believe it's your source of truth, then you need somewhere else with the same data that's stored that you trust, right? Because you don't want to lose any data, right? And so usually that place is Postgres. And so now most people already have within Postgres the data, and now you can create what we call them BM25 indexes, but search indexes on top of that data, and then just run SQL queries like you're used to. So the architecture would change. Typically, you remove one link of data movement, right? And afterwards, you route your queries. Instead of routing them to the Elastic search language or the Elastic cluster, you can keep routing them to Postgres. Another benefit you get from this is the world, as you said, has a big ecosystem around Postgres. There's so much that has been developed to make it really easy to run Postgres, to make sure multiple queries, running in parallel don't create performance decreases and so on. You can pull connections. You get to use all of these things and sort of abstract away a lot of the manual work you would need to do of setting up and maintaining Elastic.
Okay. But how does data reaches or get indexed for, the search functionality? For example, let's say I have a catalog, as you mentioned. There's probably orders coming through, customers are placing orders, there's search history and whatnot. And I want to provide, let's say, search functionality on all of this data. So how does the data that is going to the primary Postgres database, which is my source of truth, gets indexed, and how does that happen with ParadeDB?
So the way it works is we create this Postgres extension that we call PG Search. When you use ParadeDB, there's two ways to use our product. You could use our full Postgres distribution, which comes with our extensions built in. Or if you manage your own Postgres, you could just use the ParadeDB PG Search extension. Once you have that installed, which is a simple command, right, you can then create indices on top of any tables you want. So let's say you have your catalog, your products table within Postgres. You could say, create a search index over the products table. You can choose which columns you want to index, for example. You can also add tokenization if your catalog needs to be offered in multiple languages, for example. That's something that's supported as well. And then afterwards, every single new row or change that happens to your table gets automatically reflected in the search